Another kind of chi-square test is the chi-square test for independence. Now, the chi-square test for independence evaluates the relationship between two variables. It is a non-parametric test that is performed on categorical data, that is, data that is measured on a nominal or an ordinal scale. So take this example. 500 elementary school boys and girls are asked which is their favorite color, blue, green, or pink, and below we have the results. Now, using an alpha level of 0.05, would you conclude that there is a relationship between gender and favorite color? So here is our table. On the bottom, you can see that I have the column totals, 120, 180, and 200. And on the right, I have the row totals, 300 and 200. And we had a total sample of 500 people. So we can use this information to calculate our chi-square. We're going to do a hypothesis test using these same 7 steps that we always do. So step 1 is for us to state our null and alternative hypotheses. Our null is that for the population of elementary school students, gender and favorite color are not related. Our alternative hypothesis is that for the population of elementary school students, gender and favorite color are related. Now, alpha, like I said, is always 0.05. Now, calculating degrees of freedom, we're going to take rows minus 1 times columns minus 1. Now, we have 2 rows and 3 columns, so it's 3 minus 1 times 2 minus 1, or 1 times 2, which is 2. This analysis will use 2 degrees of freedom. And that's how we'll find our decision rule. We're going to go to our chi-square table, and using alpha 0.05 and 2 degrees of freedom, we find a critical value of 5.99147. So our decision rule is, if the calculated chi-square is greater than 5.99, we are going to end up rejecting the null hypothesis. So let's calculate our chi-square now. Now we're going to use the same equation to calculate chi-square, except now it's going to be a little bit more complicated to find the expected frequencies. And this is how we're going to do it. We're going to multiply the frequencies for the columns times the frequency for the rows, and then divide by the total number of subjects to get the expected frequency for each cell. So for example, let's say we wanted to find how many boys are expected to have chosen blue as their favorite color. We take the column total for blue, which is 120, and multiply it by the row total for boys, which is 300, and then we divide by the total number of subjects, which is 72. And we find out that in this sample, we would have expected 72 boys to choose blue as their favorite color. And then we can continue that to get the expected values for all 6 cells. So now I'm just going to move that up, and we have the observed values, and then next to them in parentheses, we have the expected values. And now we're going to do chi-squared like we did it before. We're going to take all the observed values and subtract the expected values, then square that and divide by the expected values to get those 6 different fractions. When we add those all together, we find a chi-squared of 276.389. So our result is, because our chi-square was greater than 5.99, it was 276.389, we will reject the null hypothesis. That is to say that in the population, there is a relationship between gender and favorite color, using the chi-square test for tests of independence.